Welcome to this explainer. Today we're jumping straight into a frankly mind-blowing scientific breakthrough. We're talking about a solution that tackles two of humanity's biggest existential threats, global warming and global food security, at the exact same time. And the wildest part? The fix comes from somewhere you would literally never expect. So, let's dive right in. Right off the bat, to really grasp the sheer scale of the threat we're dealing with here, consider this. A staggering 11% of all global methane emissions come directly from the world's rice paddies. I mean, really think about that for a second. Over a tenth of a major greenhouse gas is just bubbling up from the exact same fields that feed billions of people. And this isn't just a minor hiccup, it's a massive hidden climate threat. Because molecule for molecule, methane traps 21 times more heat in our atmosphere than carbon dioxide. It is an absolute heavyweight when it comes to climate change. To understand why this is happening, we've got to look underground. Up top, in the water and the air, things are aerobic. There's plenty of oxygen. But down below, in that deep soil zone beneath the water, it's a totally different story. It's an anaerobic environment. Oxygen-hating microbes, known as methanogens, absolutely thrive down there. As they break down organic matter in the dirt, they're constantly pumping out this highly potent methane gas, which travels right up through the plant and straight into our atmosphere. So we have a massive climate issue on our hands, right? But honestly, climate change isn't even the only problem here. Rice farmers have historically battled a devastating agricultural phenomenon called akiochi, or autumn decline. This is basically a farmer's worst nightmare. The plants look perfectly fine early on, but late in the season, right when they're supposed to be finishing up their growth, they suddenly suffer this severe root rot and just completely decline. So what actually causes akiochi? It's an underground poisoning known as hydrogen sulfide toxicity. Basically, over years of really intense farming, particularly in sandy soils, the natural iron in the ground just gets totally depleted. And when that iron runs out, any excess sulfur in the soil essentially turns into a toxic acid. It creates this hostile environment that literally destroys the crop's roots from the bottom up. Which brings us to our next section, the unexpected savior, industrial waste. The astonishing solution to both of these massive problems comes from the heavy, carbon-intensive world of metal manufacturing. Enter steel-making slag. Yeah, essentially the gritty, leftover byproducts from steel manufacturing. Historically, this was just cast aside as total waste, but scientists started looking a little closer at its unique chemical makeup. And it turns out, this supposed garbage is actually packed with iron, silica acid, and calcium. As we're about to see, feeding heavy industrial waste to delicate rice plants is, ironically, the ultimate green fertilizer. Moving on to mechanism 1, suppressing methane. Let's look at how this steel waste actually suffocates those problematic microbes. The absolute secret weapon here is the iron contained in the slag. When you apply it to the paddy, the slag releases this iron right into the soil, and it essentially acts like an oxygen-breathing armor. It's a really powerful oxidizing agent that raises the soil's oxidation reduction potential. Now remember those methanogen microbes from earlier, the ones that hate oxygen? By raising the oxidation levels, the iron effectively creates a highly hostile environment for these anaerobic bacteria, shutting down their methane production line right at the source. Next up, mechanism 2, preventing toxic root rot. We've stifled the methane, but what about that toxic hydrogen sulfide? Well, it turns out the iron saves the day again through a remarkably simple but honestly beautiful chemical reaction. As that toxic hydrogen sulfide builds up in the aging paddy soil, the iron from the steel slag steps in like a shield. It intercepts the toxic hydrogen sulfide and binds directly with it. The result? It locks that toxicity away permanently as completely harmless iron sulfide. The roots are saved, the toxicity is totally neutralized, and the plant can actually thrive. And that brings us to mechanism 3, the vitamin effect, because the benefits of this industrial waste definitely don't stop with just the iron. The other ingredients in the slag essentially act like a powerful multivitamin for the plants. Just look at the heavy lifting the silicic acid and calcium are doing. The silicon naturally hardens the plant's stems and leaves, which builds a physical defense against diseases like blast fungus, and it keeps the plant from physically collapsing under its own weight. It even helps the rice maintain its internal temperature during extreme heat. Meanwhile, the calcium neutralizes the acidic soil, bringing the pH balance right back to the absolute sweet spot for perfect growing conditions. Section 4. Global Proof and Impact. On paper, this is an incredibly fantastic theory, sure, but science demands proof in the dirty, complex reality of the real world. which naturally led to major field trials across Southeast Asia. Between 2009 and 2011, researchers took the steel slag fertilizer out of the lab and into the mud. They traveled to 17 different real-world paddy fields across both northern and southern Vietnam, right in the absolute heart of rice-growing country, to track its actual impact on yields and emissions. And you know what? The harvest data was nothing short of incredible. Out of the 17 test crops where the slag was applied, 12 showed a definitive, measurable increase in grain yield compared to traditional farming methods. The farmers were actually growing more food simply by feeding their crops an industrial steel byproduct. And even more importantly for our climate, the environmental data totally backed up the theory. Out of the 10 crops that were specifically monitored for greenhouse gas emissions, 9 of them successfully suppressed their methane emissions while still maintaining or even improving that grain yield. It was a verifiable win-win. And this isn't just a flash in the pan either. The Vietnam data aligns perfectly with historical, long-term data from Japan's Shimane Prefecture. Researchers there proved that a single application of about 500 to 600 kilograms of this slag provides a sustained 10% yield boost. Because that iron stays in the soil, the disease protection and the environmental benefits last for 3 full years before the soil chemistry normalizes and you need to reapply it. So why does all of this matter so much? Because roughly 2.7 billion people in Asia alone rely on rice as their absolute primary food source. With populations growing and the climate warming, scaling this dual-action solution, growing more food while emitting less greenhouse gas, is quite literally a matter of global survival. So I want to leave you with this final thought to ponder from today's explainer. We've spent decades trying to figure out how to clean up the mess of the Industrial Revolution. But if the heavy, gritty steel industry actually holds the secret to green agriculture, what other hidden miracles are hiding right now in our industrial waste? Thanks so much for joining me today, and keep questioning what we throw away.